started.
Oh boy. Look forward to it.
Let's learn about the Jovian planets.
You're really weird.
Page 194, 7.1.
194.
Using a small telescope, one can see the Galilean moons of Jupiter and the striped gaseous surface. Hopefully we'll be able to see this before the end of the semester. We'll take a telescope out and look at it. The rings of Saturn can also be seen through a telescope. How many have ever viewed through a telescope Jupiter or Saturn? Leah?
Mm-hmm. Once when I was little.
Nice. Well, that'll be something new for all of you. I'm going to take you to this observatory in Ludowici that this farmer has, and he's got a real big telescope, and hopefully we'll look at that. Of course, I don't know when we can do that. It has to be good weather, and usually go after the time change so that we can leave and get back relatively early, because it starts a lot earlier. So we'll figure out a good day for that, and then go.
We should spend the
It's
night
for
on the
you.
farm.
This is about what Jupiter looks like through a really good telescope. The one that the guy has that we'll go see, the real big, I mean it's big, it's like this wide around, almost as tall as the ceiling. Jupiter looks maybe half that size.
Oh.
This is a pretty good telescope here. But you can see Jupiter with its stripes, and those are called the Galilean moons, those four. And they're the biggest moons that go around Jupiter. And you can see those Galilean moons even with our little telescope here. They just look like little dots. And those are, of course, the ones that Galileo saw orbiting Jupiter. And that's what he got in so much trouble for. He was saying, hey, those things orbit Jupiter. Look at them go around and around. And they said, no, Galileo, everything orbits the Earth. You can't say that. And he's like, look. And they go, no, jail. He goes, oh, now I see. That's what Jupiter actually looks like when you get a lot closer. You can't see it that close unless you fly a satellite up to it, which we have. We've flown several satellites around Jupiter, past Jupiter. First ones that went by were called the Voyager craft. And we sent one recently called Galileo. This craft was called Galileo that went right by it, took a lot of good pictures.
I like pictures.
They have lots of good pictures of Jupiter. This is from the Galileo mission.
In the summer of 1995, the atmospheric probe separated from the Galileo spacecraft and began its own trek toward Jupiter. The probe itself has instruments that measure pressure, temperature, and chemical content of the Jovian atmosphere. Here we see the main bus of the Galileo spacecraft in its initial approach to Jupiter. As the vehicle began orbiting the planet, it monitored data from the atmospheric probe and relayed the findings back to the Earth.
That's the probe diving into
As the
Jupiter.
atmospheric probe makes its way toward Jupiter, great bolts of lightning can be seen on the dark side of the planet. These bolts can also be heard in the radio part of the spectrum. In December of 1995, the probe entered the upper layers of the Jovian atmosphere at a searing 170,000 kilometers per hour. Under its parachute, the probe relays data back to the main bus for approximately 90 minutes.
fell through the clouds and kept radioing back information until the atmosphere got so thick that it crushed the probe. The deeper you get down the atmosphere, the thicker it is, the more pressure, and eventually just crushed metal. And that thing just kept sinking, and eventually it got so hot, as you get further and further down, the gases get so hot that it melts the probe. And the probe is now part of Jupiter's atmosphere. Kind of neat.
Contributed.
So a lot of what is talks about what these clouds are made of and such was learned by that probe. Let's see what this is. Oh, can't open it. That's Saturn. Now Saturn has these really big rings. Jupiter also has rings, but the rings are so thin they aren't really seen. But it has them. All the gas giants have rings. Do you remember what the rings are from? What causes the rings?
The moon get crushed.
Yes, a moon. If a moon gets too close to a planet, it'll get torn apart by the planet's gravity and spread out in a thin disk. And so any moon that's getting closer and closer to the planet will eventually become a ring. And then the ring itself keeps falling inward and eventually falls into the planet and disappears. The whole process of a moon doing this might take 200, 300 million years of getting closer and spreading out and becoming a ring, and then the ring eventually falling in. So this ring will be gone in a few 100 million years, and probably another ring will form when another moon falls in. I mean, Saturn's got like 60 moons. Some of them are getting farther and farther from Saturn and will fly away, and some of them are getting closer and closer. And some of them are in a completely stable orbit where they aren't getting further or closer. But Saturn is also a gas giant. And the stuff it's made of, the gases it's made of, is similar to the gases that are found on Jupiter. It's mostly hydrogen and helium. Hydrogen and helium are gases that are the most prevalent atoms in the universe, and they make up most of the gas giants. But the outer atmosphere has other stuff too that gives it the colors and the stripes, like methane and other things. We'll talk about that in a little bit. The first spacecraft we sent to the gas giants were the Voyager probes. In the 70s and 80s, the Voyager probes were launched and went by all the gas giants. Went by Jupiter, then Saturn, then Uranus, then Neptune.
Not Pluto.
Not Pluto. The planets were in an alignment during those decades where all four planets were orbiting in just such a way where they were all kind of lined up. So you could launch one spacecraft and go by all four of them. An alignment like that only happens every couple of hundred years. And it happened to come by in the 1970s. So when the scientists looked at that, they said, if we don't launch now, we'll never have a shot at this again for another couple of hundred years. And so they made those Voyager spacecraft so they could go by all four planets with one launch. Actually, only one of the Voyagers, only Voyager 2, went by all four of them. Maybe it was Voyager 1, I can't remember. One of the Voyagers went by all four of them, and one of the Voyagers just went by two of them, Jupiter and Saturn, and curved off of Saturn to go look at Titan, one of Saturn's moons that was really neat to scientists because it has an atmosphere. It's the only moon with an atmosphere. So they wanted to look at that too. So one of the Voyager spacecraft did the 2 planets and Titan, and the other Voyager spacecraft did the 4 gas giants. So I talked about Galileo. It went to Jupiter in 1995 and just orbited Jupiter many I think it's still orbiting Jupiter. And then this other, Cassini-Huygens was a mission to Saturn. Cassini was the spacecraft that went around Saturn, and Huygens was a probe that landed on Titan, which is a moon around Saturn, and learned about Titan. There's a probe sitting on one of Saturn's moons right now that went through the atmosphere and parachuted down and landed on Titan. So we spend a whole day talking about what Titan looks like. It's pretty cool. These crafts, the Voyager crafts, used a technique called gravity assist that you need to know about. It talks about it on 195. It's called a slingshot maneuver. And here's how it works. Here's Jupiter going through its orbit. Jupiter just goes around the sun and moves. And if you take a spacecraft and you launch it at Jupiter, it'll start falling toward Jupiter. And you can use that gravitational energy to speed up your spacecraft. It's called a gravitational slingshot. So as this craft kind of gets close to Jupiter, it falls towards Jupiter and picks up speed. But it's far enough from Jupiter that it won't fall into it. It'll just curve around it. And at this point, it's going way faster than it was before. We can launch a spacecraft to about 13,000 miles an hour with our chemical rockets. But you can get it sped up to 10 times that fast with gravity assist. So it's going 130,000 miles an hour. 10 times the speed with no cost. All you got to do is plot your trajectory correct. And so these spacecraft are really moving. And they use that gravity assist not only on Jupiter, but on all the planets to get it going real fast. You can see here the mission from Earth. The spacecraft Voyager 1 was the one that went by Titan. And you can see it's got the brown dashes, and Voyager 2 has the blue dashes. And so they launch and they go by Jupiter and get a gravity assist around Jupiter. And then they go by Saturn and get a gravity assist past Saturn. And of course, Voyager 1 just goes by Titan and then goes off into space. And Voyager 2 goes by Uranus and gets a gravity assist around Uranus. And finally goes past Neptune. And Voyager 2 is now flying off into space. And these crafts, Voyager 1 and 2, are as far from Earth as any object we've ever launched. They're just flying out into outer space.
Do we still receive information from them?
Yes. They send back a little message about once a month or so, saying, I'm still here. Here's how fast I'm going. Here's my position. There's one of them that's set to take readings about how the solar wind acts when you get that far away from all the planets. To give you an idea, though, they've been going since they were launched in 1977. So they've been flying for 45 years. And they're still not past the Kuiper Belt. So that tells you how big that Kuiper Belt is, which is outside of where Pluto is. I mean, of course, the Kuiper Belt is kind of a disk, and Voyager 1 is going not toward anything in the Kuiper Belt. And Voyager 2, I think, is going off at an angle too. So they're not going to see anything in the Kuiper Belt. But they're not past that distance that the Kuiper Belt is. Gravity assist is very useful. They use it on a lot of missions to get going fast. There's a mission right now going to Pluto called New Horizons. It'll be there in 2017. So y'all will be just finishing college. And I want you to think, when you start seeing pictures of Pluto, go, hey, Mr. Willis said that would happen. And I want you to call me up. And I want you to say, Mr. Willis, you see the Pluto pictures? I remember when you said that was going to happen. And I'll say, hey, Olivia, thanks for calling.
How close is it?
It's 5 years off, so they launched it about 5 or 6 years ago, so I guess it's halfway there. Did we already see this?
In the Sun, atmospheric probe separated from the Galileo spacecraft and began it.
We saw that.
In 1977, Voyager 2 leaves Earth on the greatest expedition ever. With Voyager 1 just behind, twin probes en route for Jupiter. Then, with gravity assist, a change of course for Saturn. Here their paths diverge. Voyager 1 leaving the planets, Voyager 2 slingshotting onward. Uranus is reached, 9 years out from Earth. And Neptune 3 years later, in 1989. With gravity assist, Voyager 1 picked up 48,000 kilometers an hour from Jupiter. From Saturn, and an alignment of planets that happens once in 176 years, Voyager 2 sped on to Uranus. Each slingshot infinitesimally slows the planet. Voyager 2 reached Neptune in 12 years. Without gravity assist, it would have been 30, a distance so great, radio signals took over 4 hours to reach Earth. Gold-plated discs on both Voyagers carry earthly information to the stars, but the craft must speed thousands of years to reach even the nearest star.
I'll show you the last chapter of our book talks about what's on that little disc. And they said when they launched them, Carl Sagan was the scientist in charge, they said, we need to put some information on this that talks about humans and our planet in case an alien ever picks up the spaceship, an intelligent alien. And so they have discs like CDs on, but they're real big. Back then, the CD technology was infant, so a compact disc was that big. They have this big gold disc with little holes put in it that they figure an intelligent civilization could decode it. I mean, we could decode it if we found one. What's that?
Isn't that the Beatles song in there?
Yeah, they put songs and pictures and all sorts of things
They should just put a
representing
book
the Earth.
inside of it and say, read this.
And it's interesting how they made the code. They did the code based on like the hydrogen atom, and we'll talk about it in the last chapter. So there's Jupiter. It's got this big spot on it, the great red spot. And that great red spot's been there as long as we've been able to look at Jupiter. It was seen through the first telescopes. Galileo saw it with his telescope. So it's been there at least 300 or 400 years. It's a big storm. And all these little circles are also storms. Remember, Jupiter is all atmosphere. There's no land. So just like a hurricane on Earth sets out over the water and gets stronger and stronger and bigger, and then when it hits land on Earth, it kind of diffuses. But there's no land to hit on Jupiter, so these storms keep going for a very long time. They can break up, but this one hasn't. Here's a bunch of smaller storms. You can see they get smaller and smaller, and they're all over the place, swirling storms. And these stripes are like clouds. Clouds that have been stretched out so much that they go around the entire planet. And the colors have to do with different temperatures and different speeds that they're traveling. Very interesting stuff. We'll learn about it this chapter. Now, you can see Jupiter and Saturn with the naked eye. But you can't see Uranus and Neptune. With the naked eye, they aren't even stars. They don't look like stars. They're too far out there and too faint to see. And so there was a man who discovered Uranus, William Herschel, in 1781. He saw a little planet. Remember, the planets move across the celestial sphere. I don't have my celestial sphere here. And the planet, so this looked like a star, but it was moving each day. It was in a little different spot. And stars don't do that. Stars basically stay in the same place. But this star moved, and so it was a planet. And so he almost named it George, after King George. So we almost had Planet George. But somebody said, nah, you ought to name it after a Greek god or something, because that's what all the other planets are named. Jupiter and Saturn, they're Greek gods. Mars. And he said, okay, I'll name it Uranus, which is some sort of Greek god. And even through our big telescopes, it just looks like a greenish-blue dot. But when we flew that Voyager mission, and we got real good pictures of it. Now, when they started looking at Uranus, they noticed that it wasn't where it was predicted to be. After a month, you'd predict it to be right there, and it was a little bit different spot. And after 3 months, you'd predict it to be right here, and it was in a different spot. And the only thing they could figure out from this perturbation of Uranus's orbit was there must be another planet out there just affecting it gravitationally. And so the search was on for the next planet out. And they found that planet. It was Neptune.
Yeah.
And Neptune does affect Uranus a little bit. And you could actually mathematically figure out what was wrong with Uranus's orbit to find out where Neptune was. It's a big math problem. That's Uranus. Not too exciting, huh? It's so far out and it's so cold that you don't get as much heat rising from within. You don't get as much circulation as Jupiter and Saturn, so it ends up being a different color, more uniform. Even though it's made of basically the same stuff that Jupiter and Saturn are made from. That's Neptune. Neptune's got a little bit more character. We'll talk about why that is. It's cold there. Something like 20, 30 degrees above absolute zero. And Neptune had a big storm too. It was called the Great Dark Spot. But that storm disappeared about 10 years after Voyager went by. 20 years after Voyager went by. When they launched the Hubble Space Telescope, it could look at pretty close enough at Neptune to see if that storm was there. It couldn't look this close, but it could look at it pretty well, and that storm was not there. So that storm disappeared between the time Voyager went by and the time the Hubble Space Telescope was made. Hold on, let me see if we need to keep going here. We do not. So you read 7.1 and 7.2, and then we'll talk about what these things are made of tomorrow. And I'm going to show you that atmospheres video. It's not. I can't access it. Something's wrong with the computer, so I got a different video to start. think you'll like this one better anyway.
She's making a weird face.
You can turn off the
Okay.
recording.